Today, we're going to continue our discussion into the topic of pressure by looking at another form of pressure, okay, which is atmospheric pressure. So if you remember from our class before this, okay, we looked at pressure that is caused by liquids. Okay, so liquid bila ada cecair kan, so liquids in a certain container or anything, okay, put pressure on us lah, okay, or put pressure on any object that is underneath that is, dia mengena the weight of the liquid. Okay, and we looked at the formula for pressure in liquid, which is P equals to rho GH, and we will be talking about this in a little while lah. Okay, maybe in the next class, but not today. But today I just kind of want to give you an overview of this kind of pressure, which is called the atmospheric pressure. Okay, so today I hope that we can at least do 2.2.1 and 2.2.2, and tomorrow or whenever our next class is, I want to do 2.2.3 and 2.2.4. Okay, so this is a photograph showing a glass sheet, okay, that is lifted using this large rubber sucker. So you have all these rubber suckers over here. You know the thing that you put on the wall, kau kasih pacakkan, terus kau bila kau tarikan dia boleh it can hold a very significant amount of weight lah. I'm not saying that it's super strong lah, but it can hold up quite a lot. Okay, and actually this thing called the rubber sucker okay, is actually using the atmospheric pressure. Atmospheric pressure is actually helping the rubber sucker to do its job. Okay, and that's why you see, walaupun ini adalah kaca, okay, this is a glass sheet, you have all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rubber suckers acting on it, and kau tarik saja pakai this one string over here, okay, and you are able to move the glass sheet. So how does atmospheric pressure, okay, help us in this area? Okay, same thing like the plastic sticker that you see on the car lah. Okay, actually if you take out the car, the car sticker, right? Actually, if you stick it on your arm, kan dia tidak melekat sebenarnya. It's not very sticky. It's not like the kind of sticker. Bukan stiker yang macam kau lekat dalam stiker buku bahkan. Kalau kau lekat di atas kau punya tangan kan, terus kau tarikan, terus terikutlah kau punya bulu tangan lah. But the car sticker, like the one they have for the road tax and everything, atau sorry, I don't know whether anybody in this class already has a driving license now, but if you have a driving license, you know that one of the things you need to put is the P sign. And you have to put this red color sticker and then the white color P words bahkan. Okay, but you see, actually if you take out the sticker kan, kalau lekat di tangan kamu kan, dia tidak melekit sebenarnya. It's not sticky bah. So if it's not sticky, how is it able to stick on the windscreen? How is it able to stick pada cermin kereta without falling off? Okay, so actually what happens is they are actually pressed on the glass surface by atmospheric pressure. Okay, so atmospheric pressure actually is all around us. We don't realize it's there because bila kita dilahirkan kan, when we are born, we already live with atmospheric pressure. Okay, selalu kita cakap kan, oh tekanan, but actually every day kamu dikenakan tekanan. Cuma kau tidak sedar. Because you have lived with this pressure every day. Okay, but once you know how much is the value of the atmospheric pressure kan, you'll be surprised that wow, saya punya badan rupa-rupanya boleh menahan pula tekanan begitu besar. Okay, I'll come to that in a while. Okay, so I want you to look at this situation now. So this guy, he's at the bottom of the mountain. Okay, and usually when you are much nearer down the mountain, there is more air. Okay, lebih banyak udara lah berbanding dengan when you are at the peak, when you're at the top. Because the higher you go, okay, the higher from sea level so this is what we call sea level. Okay, paras laut lah. Okay, sea level does not always mean the sea lah, but at the sea level. But the further you are from the sea level okay, the less air there is going to be. Okay, so that's why this box over here, look at how few atoms are pressing down on the guy at the top of the mountain. And then look at how many atoms, how many gas atoms are pressing down on this guy who is at the bottom of the mountain. Sorry, please turn on your cameras, everybody. I keep forgetting to say this. Okay, another thing that I want to mention is the difference in sea level. This word, I want you to get used to this word. It is called altitude. Okay, altitude is ketinggian kamu dari paras laut. So the higher the altitude, we find that there is less air. Okay, and because there is less air, we say that the person on top of the mountain experiences a lower atmospheric pressure. Okay, manakala the person at the bottom over here, he experiences a higher atmospheric pressure. So the altitude makes a difference. The bigger the altitude, the lower the atmospheric pressure. I repeat, the bigger the altitude, maksudnya kau makin berada di tempat yang tinggi kan, okay, your atmospheric pressure will be lesser. And that's why, I don't know how many of you have done this before, but I'm very proud to say that I've climbed Mount Kinabalu 4 times. Okay, so each time I climb Mount Kinabalu, I will face the same problem. All of us climbers, we face the same problem mau sampai ke puncak. Because when you are nearer to the peak, there is less air. Okay, there's less air and the atmospheric pressure is lower. So it's harder for you to take a breath. You know, kalau let's say, for example, at sea level, you can run 100 meters and non-stop, because there's a lot of air, there's a lot of atmospheric pressure, there's a lot of atmosphere. Okay, so you can take in breath very easily. But you try running 100 meters at whatever fitness level you all are, you try running 100 meters on the top of the mountain, you're going to find that it's very different. Okay, you may find that you halfway, you need to stop because you're not getting enough air into your body. Okay, because di sana atmospheric pressure is much lower and it takes a lot more effort from you to take in the same amount of air. At sea level kamu macam tu saja kan, banyak sudah udara masuk. Tetapi kalau kamu mau the same amount of air on top of the mountain, you have to take a bigger breath. Baru sama. Okay, baru sama kamu punya the amount of air. Okay, because on top of the mountain there is much less air. Okay, so bukan sebab kamu penat lah atau kamu tidak fit tau. Sometimes it's just your surroundings lah. The lower atmospheric pressure on top of the mountain means that there's less air, and that's why it is harder to climb a mountain as you get nearer and nearer to the peak lah. Okay, but if you have never climbed Mount Kinabalu, I really encourage you, go and climb. Okay, it's an amazing experience. Everyone should experience climbing Mount Kinabalu like once in their entire life. Okay, so that you can experience macam mana perasaannya kan bila itu udara kurang and you're like setiap 3 langkah you have to stop. 1, 2, 3 then you stop untuk mengambil nafas. Okay. Okay, I'm a bit exaggerating lah. It's not really 3 langkah lah, but depends on your fitness level lah. Some people kan 3 langkah dia kena stop, 3 langkah dia kena stop. Okay, but the idea is not to give up. Okay, so atmospheric pressure is the pressure due to the weight. Okay, pressure due to the weight of the layer of air acting on the surface of the earth. Okay, so you have all this air around it. Okay, and because they are all acting on the earth, so it creates a pressure on us lah. Okay, so the earth is surrounded by a thick layer of air, okay, consisting of various types of gases. If you remember your geography, ada this sphere, stratosphere, something sphere, bahkan. Okay, so that's geography lah. But for us, we know that it's different types of gases, and this layer of air has weight. Okay, because dia ada berat, dia akan mengenakan tekanan. It will exert a pressure on the surface of the earth as well as all objects on it. We don't realize it, okay? Kita tidak sedar. Sebab bila kita dilahirkan kan, when we are born, we already feel the atmospheric pressure. And we grew up with atmospheric pressure. You don't realize it. Okay, but you will realize it, mana tahu one day kan, one of you will become an astronaut lah. I mean, okay? One day, one of you will become an astronaut and you will finally feel how it feels that when there's no atmospheric pressure. It literally feels like a weight has been taken off your shoulders. It's literally like that. Okay, saya bukan cakap yang saya tahu lah, tapi that is the description that people tell me lah. Sepertinya satu beban bahkan jatuh daripada kamu punya bahu. Okay, that's how atmospheric pressure feels. But we don't realize it because we carry it with us, Oh, macam beban hidup pula. Sorry. We don't realize it because we are born into atmospheric pressure, so we don't realize it because it's always there with us. We are used to it. Okay, but you know, when the pressure is taken off you, wow, I want to know what that kind of feeling is, lah. Yeah, maybe I should ask an astronaut one day. Okay, anyway, so all objects on the Earth, okay, experience atmospheric pressure. Okay, video, Kali. Yeah. So this is one of the applications of atmospheric pressure. So a yeah, picture postcard. Can you guys hear the music?
Oh, dia punya suara dah kuat.
Oh, okay. Okay. So the air pressure exerted on the card from underneath is greater than the weight of the water inside the glass. That's why the card manages to hold up the water and not let it spill out. Okay, this is something that actually everybody has done this lah once in their life. I hope that you all have done this once in your life lah. You know, you put this on and you put a card, but the syarat is itu air mesti betul-betul penuh lah. Cannot be ada ruang udara di sana. It has to be really full. Then you put the card on top and you terbalikkan. Okay, and what happens is, so let's say terbalikkan lah. Okay, what happens is outside here there's this atmospheric pressure that is pushing the piece of paper. Okay, this water di dalam gelas ini dia sebenarnya menolak the paper. Logically if you think about it, mestilah the paper turun bahkan. Then you're like, wow, come kids, this is a magic show. Take a look. What happens if I take away if I take away my hand? Then all the small kids will be like, oh, the water will drop out. No. And then semua orang akan takut kan. This is very normal. Okay, tapi, okay, ready I'm going to take away my hand. 1, 2, 3, like that. Then all the kids will be like, wow. Okay, padahal there's nothing wow about it. Okay, scientifically, how we explain it is because there's atmospheric pressure. But don't tell this to kids lah. Don't go and kacau your adik-beradik and say, come, let me show you. Kau tahu kah kenapa ni? So, tekanan atmosfera. Dia tampar muka kamu itu. Dia tidak mau tahu. It's better to know it as magic. Okay, but this is the reality. No matter how heavy your water is, okay, the atmospheric pressure, most of the time, the atmospheric pressure is great enough. Okay, there are situations where the weight of the water is bigger than the atmospheric pressure, but you need to know the atmospheric pressure is very big. Okay, dia bukan sekadar satu mangkuk air atau satu periuk air. Even periuk air, if you really want to test this, go and test this with a periuk. Okay, kau ambil satu periuk yang besar kan, kau letaklah satu kad manila di atas, maybe you need 2 or 3 people to help you to do this lah. Then you terbalikkan the thing, and then you let go of your hand. You see whether the periuk air itu kan masih boleh bertahan atau dia akan tertumpah keluar. Okay, most of the time the periuk air will still stand because that's how big atmospheric pressure is. Okay, sorry, you're looking at this black screen. I don't know. Okay, sorry, another guy. Can you guys hear?
No.
Oh, okay. So this. Okay, so this is hot water, and he's pouring it into a plastic bottle. Then he's closing it. Okay, now he's pouring cold water. Okay, then look at this one. Look at the bottle. Dia macam sepertinya kemek. Okay, so yeah, inside is hot water, outside is cold water. So when you pour cold water on a hot bottle, yeah. Oh, sorry. Okay, so basically, basically what happened was, so when you pour the cold water onto the hot bottle, right? So itu gas yang panas, the steam inside the bottle, dia akan condensate. Okay, dia akan kondensasi and become water, and so that means there is less air inside the bottle itself. Okay, dalam inside the bottle itself, kalau kita isi dengan air kan, memang kurang sudah udara lah. Okay, dan bila kamu tambah lagi air sejuk, okay, dan kau tutup ini kan, okay, so the steam inside here dia akan condensate untuk menjadi air. You change to become water, so even less air. So because of that, the atmospheric pressure yang berada di luar, dia akan menang lah sebab tiada sudah, kurang sudah gas di dalam, kurang sudah steam di dalam botol. So the atmospheric pressure will push the bottle and kasih kemek the bottle. Okay, that's basically what is happening lah. Okay, in this situation. So as I said just now, human beings living on land are surrounded by air. We are always surrounded by air. Okay, we never think about this. Sejak kita lahirkan, we already see this. Explain the existence of atmospheric pressure on human beings from the aspect of weight of air acting on him. Yeah, so air is not just empty space. Okay, they are the GSM, they are the substance. Air has molecules that are constantly moving because air has mass. Okay, so mass times gravity will give you weight. And because there is weight, the air molecules are always bumping into things, and therefore kamu akan dikenakan tekanan. Remember the formula for pressure, the original formula for pressure is P equals to F over A. The F over here is the weight of the gas, weight of air lah. Okay, and then the A is the area of the object. So if the object is, let's say this is the area, okay, and this is the weight kan. So pada tempat ini kan akan dikenakan satu tekanan. And kalau the surrounding this boy, okay, is all air, so every part of the boy ada area lah bahkan, and every part of the boy akan dikenakan satu tekanan. Okay. So atmospheric pressure at sea level, at our level lah. Okay, so the value of atmospheric pressure at sea level, this is in your book okay, is 1.03 times 10 to the power of 5. Okay, Newton per meter squared or pascals. Okay, let me tell you realistically how much it is. It is 10350 okay, 1, 2, 3, 4, 5. Okay, pascals. 103,500 pascals. That's a lot of pressure. Okay, that's a lot of pressure yang kita sebenarnya sedang menanggung sekarang. It is a big amount. Okay, how much weight of air is exerted on our body per 1 meter squared? Okay, it is about, it's about 103,000 newtons for every meter squared of your Okay, so if you know how, I don't know if you have learned this before, but if you know how to count the area of your own body, okay, every 1 meter squared, okay, every 1 meter squared is 103,000 newtons of force on you. Okay, let me give you realistically, 103,000 newtons is about okay, is about it's about 10300 kg. About. Okay, lebih kurang. Okay, 10,300 kilograms. Sorry, saya bahagi dengan 10. Actually, you're supposed to divide by 9.81. But 103,000 newtons is about 10,000 kilos of air on you. Okay, kamu mengangkat beg sekolah kamu yang tidak sampai 30 kilo pun kamu mau komplain. Bayangkan the amount of air on you is about 10,000 kilos. Okay, and you want to tell me that that you you cannot handle pressure. It's totally fake. You totally can handle pressure because every day you live with 10,000 kilos, okay, of weight on you. Okay, imagine 10,000 kilos. 10,000 kilos is wow. Okay, it's unimaginable. No? I cannot imagine 10,000 kilos per 1 meter squared. So let's say for example okay fine. Say for example, let's say just my body, yeah? Okay, my body is about maybe 1 meter times 0.5 meters lah. Okay, let's say for example lah, so it's about 0.5 meters squared. It means on my body kan, I am actually feeling about 5,000 kilos of weight on me. Okay, just my body. Kalau saya beranggaran sahajalah. Okay, so people, okay, sedikit motivasi lah untuk hari ni ya. If you think that you cannot handle pressure, just remember how much atmospheric pressure is acting on you every day of your life since you were born. Okay, and you're still living. Okay, kamu masih hidup, kamu belum, you're not dying or anything. Okay, you're still living, so you can handle this pressure. Okay, if you can handle atmospheric pressure, you can handle any pressure. Motivasi betul. Okay, so why is our body not crushed by the huge atmospheric pressure? So it makes sense, right? Kalau ada tekanan yang besar, pastilah kita kemek makan. Because most of the fluids in our bodies are approximately at the same pressure as the air around us. Remember, dalam badan kita ada banyak cecair. Dan cecair mengenakan tekanan. Which is why it's very important to drink water every day. Okay, some people they think they're very hero, lepas tu tidak minum air. No, okay, water, okay, fluids in our bodies help us to make sure that the pressure that we feel from the atmospheric pressure is balanced. Okay, otherwise, kita akan terkemek. Kita akan terkemek ke dalam, So, my second advice for you today is make sure every day you drink a lot of water, okay? At least 2 bottles or 8 glasses a day, depending on which person's advice you want to follow. Okay, otherwise, alahai. Okay, so please be careful with this. Okay, let's watch another video. Today got a lot of watching videos. I still don't know why. Oh, sorry. Sorry, can you guys hear the video?
No.
No.
Not really. Sorry, I can't adjust the volume. I mean, I'm at my maximum already. Like langsung tiada bunyi kah?
Yeah.
Really? How about now?
No.
Pun tiada bunyi? Oh no. I must have forgotten to turn off the... Okay, never mind. I shall just explain what's happening. Okay, so the guy is riding a bike, a unicycle, sorry. For some reason, he can jump across this one, and go pada tali. La la la. He's singing a song, by the way. Okay, so some more string lah. Okay, ada tali. Okay, so now there's a atmospheric pressure. So lower the atmospheric pressure. What happens? Kenapa dia rasa macam dia meletup? Do you notice that when the atmospheric pressure is low, suddenly dia dapat itu pening kepala, and then he feel that if you can hear the sound, actually there's a pop sound lah. Kenapa ada pop sound? Okay, so and he falls. He loses his balance and he falls. Okay, his ears pop. So when the atmospheric pressure is low, okay, your ears will pop. And this one maybe Elijah can explain to us why lah, because this is a pilot kind of thing lah. Okay, so our Earth is surrounded by a layer of air called the atmosphere. Okay, so this is atmospheric pressure on the Earth, on the object. Okay, kau boleh baca lah di sana. Okay, this is a very important thing. So the atmospheric pressure outside our body is balanced by the air pressure and the liquid pressure inside our body. Okay, that's why we don't feel anything lah. Okay, because the amount of pressure that kita kenakan pada atmospheric pressure, okay, balances each other. Okay, so when just now, if you remember the situation, when you lower the atmospheric pressure, we find that the air pressure inside now is becomes higher than the atmospheric pressure outside. So what happens? Okay, so when we decrease the atmospheric pressure, okay, yeah, in just now the unicycle situation, when we decrease the atmospheric pressure, what happens is outside atmospheric pressure is less than the inside of our bodies. Okay, so the reason why our ears pop, kalau kita, I mean, if you fly enough on the planes, you will realize this. The higher we go, okay, our ears will pop actually, because the changing pressure. Okay, the pressure becomes lower because kita makin jauh daripada bumi bahkan. So the reason for that pop is because our inside body punya pressure needs to balance. Okay, pressure always seeks to find a balance lah. Want a balance dengan this one. So the high pressure inside akan berkurang, yang menyebabkan kita punya telinga pop. Sorry, I don't know what this guy is doing lah, but okay. Okay. So when you reduce the atmospheric pressure and you try to drink water, you try to run, when you increase the atmospheric pressure, yeah, you find that the bottle is crushed lah. Okay. Gosh. Yeah, so when the airplane lands, okay, if you've flown enough in the airplane, if you have an empty water bottle or just a bottle of water that's filled with kan, when the airplane is landing, you find that the bottle is crushed because the atmospheric pressure is increasing. Kan, the nearer, as I said just now in the beginning, the bigger your altitude, the lower your altitude means kamu rendah lagi ke sea level kan, your atmospheric pressure will increase. So the bottle will feel the increase in pressure. Okay, I don't know if you can hear this just now, but what the lady said was when you open the bottle inside the airplane, so the pressure inside the bottle will follow the pressure inside the airplane, which is generally lower. Okay, because dia berada di, on top lah. So inside the plane, actually the cabin pressure is actually much lower, okay, than the outside surrounding atmospheric pressure. So when you open the bottle, okay, lepas kamu buka itu kan, the pressure will balance itself out. So the pressure inside the bottle will become the same as the airplane pressure, which is low lah, okay, lower. But when your airplane lands and you come out, you find that the bottle, yeah. So the atmospheric pressure will be much bigger than the pressure inside the bottle. That's why the bottle will be crushed. So dramatic. Okay, third situation. Sorry, I have no idea what's happening, but I'm trying to make sense of what's happening. Hold on now. Okay, how is this guy able to lift such a heavy car? Okay, this is what I meant by I said just now. Actually, to some extent, we are actually carrying a lot of pressure, okay, on us. Okay, of course, just now, just now is a little bit exaggerated lah. Okay. Okay, at sea level, atmospheric pressure is about, PSI is a different unit, but it's about 103,000 pascals. So kenapa kita tidak rasa? Astaga, alamak. Sorry, I terpress next. But anyway, that's the basic point of this lah. Okay, semua yang saya cakap sebelum ni kan is given in this video. Yeah, you know what? I'll share the video with you all later lah. Okay, I feel so sad that I have to give a commentary, and I don't know how many of you can hear it, but I'll send it to you later lah. Okay, together with the weird animations and everything. Okay, so the second thing I want to talk about is the apparatus, okay, to measure atmospheric pressure. Okay, so this is what we call a mercury barometer. The word, sorry, some people call it barometer and some people call it barometer. Okay, tapi dalam bahasa Melayu adalah barometer. Okay, so barometer mercury, mercury, as you know, okay, mercury is the substance that is inside the thermometer. Okay, so we fill this mangkuk besar, we fill this tube kaca, okay, this glass rod with mercury, and then we make sure that there's no air on top, then we close it. And after that, we terbalikkan inside this mercury. Okay, inside another bowl, which has also mercury in it lah. Okay, so we find that the value of atmospheric pressure, we can actually measure by using this thing called a mercury barometer. Okay, so we usually put it about 1 meter long. Okay, for nanti saya akan cakap kenapa lah. Okay, so initially the glass tube is filled with mercury and covered with a lid, penutup. Dan selepas itu kita kasih terbalikkan dan masukkan ke dalam satu mangkuk yang juga penuh dengan mercury. Now this is what will happen. Okay, I must not press. You still cannot hear anything, right?
Yes.
Okay, so there's a 100 centimeter, the other end is open. So you put a funnel over there. Then you pour mercury. Okay, wow, hebat. Okay. Okay, then after that you kasih terbalik lah. Okay, and then you put inside the mercury. I don't know how this guy's hand can survive mercury lah. Yeah. Okay. So you put a retort stand to support this 1 meter, this one. After what happens is the level of mercury will fall, and after that it will stop falling. Okay. So the height, the height from the surface to this one is about 760 millimeters or 76 centimeters. Okay. So we conclude that this is the atmospheric pressure, 760 millimeters Hg. Hg is the unit for mercury. Okay, so this blank space is called a Torricellian vacuum because it was identified by this scientist named Torricelli. So when you increase the altitude, bila kita ni less pressure. So less pressure, so the mercury column will menjadi lebih rendah because there's less pressure Okay, aeroplanes, we use barometers, okay, without mercury lah. Okay, but this is called an aneroid barometer because there's no liquid inside. Okay, so there's two types of, There are two types of barometers lah. One is the barometer that uses liquid, and the liquid that we use is mercury. Okay, kenapa mercury is something that you can discover later lah. Okay, but their second type of barometer is called a aneroid barometer. Okay, and aneroid barometer is one that we use in planes. If you go hiking, usually the houses on top of on top of the hills, they will usually have a barometer that is non-liquid lah. Just to tell you the altitude in which you're at and the atmospheric pressure that is around there. Okay, so this is the situation I said just now, and remember this vacuum is called a Torricellian vacuum. Torricellian vacuum. Okay, because Torricelli is the guy that discovered this lah. Okay, so the vacuum means there's no gas at all. That means sebenarnya what happens kenapa the mercury daripada penuh dia akan turun because what happens is that the mercury, okay, actually what happens is the atmospheric pressure pushes the mercury until a certain level that is 76 centimeters. Kalau dia terbalik, means that the mercury is pushing, the weight of the mercury is pushing the atmospheric pressure until the mercury weight and the atmospheric pressure, the pressure because of the weight of the mercury and the pressure because of atmospheric pressure until they're balanced. Once they're balanced, then this mercury will stop falling. And time and again, experiments have shown us that the height of this, okay, is 76 centimeters, which is why the value, just now I said, value of atmospheric pressure is 1.03 times 10 to the power of 5 pascals. Remember? Or Newton per meter lah. Another value of atmospheric pressure is 76 centimeter mercury or 760 millimeter mercury. This and this is exactly the same value. Okay, cuma nilai dan unit yang berlainan sahaja. Okay, and in the next class, we will talk about both situations. When do we use Pascal? When do we use centimeter mercury? Okay, notice that I don't say centimeter Hg, I say centimeter mercury. Get used to this unit. Okay, kenapa centimeter mercury? Because we are using mercury. Okay, so a common question I get is, why do we use mercury? Why don't we use water? Water is so cheap, you can do it anywhere. Okay, because the value for atmospheric pressure for water, okay, if I use water, it is 10 meters water. Yeah, the value for atmospheric pressure, if I use water, okay, this height is not 76 centimeters, no, it's 10 meters. Okay, where are you going to find a 10-meter glass tube? You know how long 10 meters is? I'm only 1.7 meters. Okay, if you want to use water, it's 10 meters, you know. Okay, so that's why we don't use water. Okay, but notice that whatever material you use, whether you use mercury or you use water, okay, you put the chemical symbol behind the unit. So if it's water, then the atmospheric pressure will be 10 meters. The height of the column will be 10 meters. If it is mercury, because mercury, the symbol for mercury is Hg, okay, so it will be about 76 centimeters or 760 millimeters. So why does the mercury level not drop further? It's because the atmospheric pressure is supporting the mercury. So at point A is atmospheric pressure, at point B is mercury pressure. Okay, so this mercury yang menolak pada point B. So the pressure at point C over here, okay, over here will be a vacuum because it will be zero because it's vacuum lah. Okay, so compare the pressure at point A at point B, because they're at the same height, the pressure will be the same. Okay, so if anything I want you to remember that for now as a starting, remember that atmospheric pressure, there's at least 3 units. 3 values with different units. If you're using Pascal, it's about 1.03 times 10 to the power of 5. If you're going to use centimeter mercury, it's 76. If you're going to use meter water, ini paling jarang lah, tapi saya kena dedahkan juga. Meter water is about 10 meters. Okay. Okay, I'm not going to do this first because this is calculation question. I'll talk about this another day. But okay, so this thing, So the height of H will remain unchanged, okay, when the diameter of the glass tube increases. You use a big diameter, you use a thick glass tube or use a thin glass tube, kan, the H will still be the same. It will still be 76 centimeters. Okay, if the glass tube kau kasih sengit pun, okay, like in this situation, okay, it will still be 76 centimeters. Cuma mungkin the vacuum over here will be much smaller lah. Okay, if you push the, let's say okay, kau tengok ini atas bahkan this glass tube is a little bit higher, this glass tube is a little bit lower, but the height of the mercury column is still the same. It's still 76 centimeters. Okay, if you push ke dalam, kalau kau tolak ke atas, it is still the same. The height will never remain different. You tambah mercury di sini pun tetap sama. Okay, tetap 70. There are only two situations where the H will change. Okay, H tidak akan menjadi 76 kalau number one, the vacuum over here, I fill it with gas. Then this won't be 76 because there is gas pressure. Okay, yang sedang menolak. Okay, or kedua, the barometer is carried to a mountain. Okay, if you remember from the video just now, at the mountain, okay, mountain means lower atmospheric pressure. Lower atmospheric pressure means the value of H will reduce. Okay, so these are the only two situations where the height will change. Okay, the height will increase when the barometer is slowly submerged in water. Kalau kita masukkan this whole thing inside water, why do you think the H will increase? Why is it that this will become even bigger, more than 76? Anybody want to try? I think the answer is in the textbook. Think about what happens when you push stuff inside water. Yeah. Anybody? Oh, sorry. I thought I disappeared. Okay, so because when you go inside water, you increase pressure, kan? So you increase pressure means outside it's not just atmospheric pressure, it's also liquid pressure yang menolak our mercury up. Okay, so that's why the barometer will, the height of this one will increase because mercury tidak cukup kuat untuk menolak the atmospheric pressure. Okay, because there's a lot of pressure from the liquid around us as well. Okay, all right. This is another kind of barometer. Okay, and sorry, this is in Malay. So this is, I think, what we call the 14 barometer. Yeah. Oh yeah. Okay. So this is the 14 barometer. Okay, I think it is in your textbook in page page 51. Okay, page 51. Currently at our level, in our lab, there's no 14 barometers, so I can only show you this lah. Okay, but the basic, it is still a barometer. Okay, but the 14 barometer uses the same situation that we saw just now. Okay, if you remember this situation, it uses this situation we saw just now, except that there is a scale lah. Okay, there is a scale over here. Okay, that will tell you the value of the atmospheric pressure. Okay, so this is how it works. It's a mercury barometer that measures atmospheric pressure to a high degree of accuracy. It's quite accurate. Okay, the 14 barometer has a height of almost 1 meter because we only need maximum of 76 centimeters. Maximum atmospheric pressure we can experience on Earth. Okay, it's about 76 centimeters. So we don't really need it. We don't really need sampai like 10,000 lah. Okay, the instrument is usually used to measure atmospheric pressure at meteorological centers. Tempat-tempat cuaca kan? Okay, or yeah, weather vanes or places where they have to measure catchment of rain or things to do with weather. Usually you will see a 14 barometer over there because we want to know what is the atmospheric pressure like at that place. Okay, the second one is called an aneroid barometer. And the aneroid barometer, I think, is explained in this next video, which I also don't know if you can hear, but I'm just going to play it anyway. Okay, Okay, barometer is instrument used to measure atmospheric pressure. Okay, two types of barometer: liquid barometer, which is the 14 barometer, aneroid barometer, which is the non-liquid barometer. The word aneroid actually means no liquid. That's why it's called aneroid barometer. Okay, it does not use any liquid, but it still can measure atmospheric pressure. Okay. So the aneroid barometer, same picture as page 51. This is, yeah. This is the semi-vacuum metal box inside your textbook. Okay, so there's a diaphragm over there. Okay, so the diaphragm will expand or contract. Dia akan mengembang atau mengecut bergantung kepada the atmospheric pressure. And the mengembang dan mengecut of the diaphragm will change the central lever yang akan memberikan kamu bacaan atmospheric pressure. Gosh, I have to explain this. And there's a voice in my ear. Okay, sorry, it's spring. Oh no, how long is this video on Instagram? Oh, sorry. So long. Okay, so this is a very long explanation of the barometer. Oh, interesting. Yeah, so this whole system tells you, it moves the pointer to tell you the reading of the atmospheric pressure. Okay, this is a pretty long. So I want to talk about the advantages. Okay. So the advantages of aneroid barometer. Number one, it's very flexible. Okay, you can, it's not flexible, it's very portable lah. Senang mau dibawa mana-mana, kau boleh letak di mana-mana. Okay. And then you don't have to adjust it before. Okay, not like the 14 barometer, got to adjust. It's hard to bring the 14 barometer anywhere. Okay, no liquid, so that's why you have to worry about the spilling over any liquid. 14 barometer uses mercury people. Okay, so it's very worrying lah. Okay, oh dear. Okay, so difference between 14 barometer and aneroid barometer is in page 52, okay, of your textbook. So the first of all is 14 barometer, the value of atmospheric pressure is determined by the height of the mercury column. So the height, sometimes you can read wrongly, but unless there's a scale over there. But the aneroid barometer is determined by the changes in the semi-vacuum metal box. Remember the diaphragm just now that you saw? Okay, so once that one changed, the aneroid barometer will change as well. Secondly, the 14 barometer is large and is not very portable. Okay, it's a huge hassle to carry. Cuba kau bayangkan kau mau bawa 1 meter punya tongkat mana-mana kau pergi. Okay, it's very not portable. Tapi aneroid barometer is very small. Okay, you can bring it anywhere. It takes a long time to get the reading for 14 barometer because it's determined by the height of the mercury column. But aneroid barometer is quite fast. Okay, you put it anywhere. Okay, whatever that because dia bergantung kepada the atmospheric pressure totally, and it just changes in a semi-vacuum metal box. So you can totally read it there and then. Don't have to wait for adjustment period. Okay, but the good thing about the 14 barometer, it has a higher accuracy, up to 0.1 millimeter Hg. Okay, manakala the aneroid barometer gives you a ballpark figure, but not really an accurate figure. Okay, so the differences are sometimes good, and sometimes good for the 14 barometer and good for the aneroid barometer. So it greatly depends on what you want. If you want something that is more accurate, lebih tepat, for some reason or another, we will use the 14 barometer lah. Okay, but if you just want to get anggaran saja, but you don't want to have the hassle of mengangkat sini, mengangkat sana, then you use an Aneroid barometer. Okay, of course, in terms of safety, Aneroid barometer is much safer lah, because it doesn't have mercury. 14 barometer has mercury, and you know, if you get mercury poisoning, it's a very big deal lah. It's not a good thing. Okay. So, yeah, you know what? That's it for today. I just wanted to talk to you about what is atmospheric pressure, okay, and what are the values of atmospheric pressure, and the dua alat yang paling utama yang digunakan untuk mengukur atmospheric pressure.